this video, I am going to simplify two questions based on Nyquist rate. In the last video itself, I already explained about sampling theorem and Nyquist rate. Here, the Nyquist rate states that when the sampled signal is going to be obtained from sampling process, the original signal can be reconstructed based on the formula. The sampling frequency Fs must be equal to the twice of the maximum frequency Fm. Now by using that formula, we are going to simplify the two questions. Now for the first question, here is that a signal having a spectrum ranging from DC to 10 kHz is to be sampled and converted into discrete form. What is the minimum number of samples per second that must be taken to ensure recovery? Here in this question, they given the range of frequencies are from DC to 10 kHz, means from 0 to 10 kHz range of frequencies they mentioned, and asking that to find out sampling frequency Fs. So here the maximum frequency given Fm will be equal to 10 kHz, and from Nyquist rate the minimum number of samples per second that must be taken to ensure recovery is Fs equal to 2Fm. So by substituting Fm 10 kHz in this equation, the Fs sampling frequency we can find it as 20,000 samples per second are required to reconstruct the original signal. So this is the explanation to simplify this problem. Now we will see the second question. A signal x of t is equal to sinc of 150 pi t is sampled at a rate of A case 100 Hz, B 200 Hz, C 300 Hz. For each of these three cases, can you recover the signal x of t from sampled signal? So in this question, we have the sampling frequency Fs. So here they mentioned the sampling frequencies are in three cases, like Fs will be equal to 100 Hz, or Fs will be equal to 200 Hz, or Fs will be equal to 300 Hz. So with these sampling frequencies, if we are able to reconstruct the original signal or not, we are going to find out. Now, before going to simplify this question, here we are considering some signal waveforms regarding rectangular pulse function and the sinc function. So, here this signal is showing the rectangular pulse function, and after applying Fourier transform to this rectangular pulse function, we are going to find the sinc function. And vice versa, here is the sinc function waveform, and after applying Fourier transform, we are going to find the rectangular pulse function. So here, by applying Fourier transform, we are converting time domain signal into frequency domain signal. And here also, if you apply Fourier transform to this sinc function in time domain, we are going to find the rectangular pulse function in frequency domain. So by seeing these waveforms for the given question, here they mention a sinc function in time domain. So after applying Fourier transform, we are going to find the rectangular pulse function like this. So here the maximum frequency is going to be from minus 150 pi to plus 150 pi. Now we will see all these three cases by considering sampling frequency Fs. Now from this figure, the maximum frequency omega m will be equal to 150 pi. Now omega m can be write as 2 pi Fm, so that Fm will be equal to 75 Hz. But the Nyquist rate states that sampling frequency must be equal to twice of the maximum frequency Fm. So sampling rate as per this Nyquist rate, we can find it as 150 Hz to this problem. Now considering all these three cases, A, sampling rate Fs will be equal to 100 Hz here. So The sampling rate is 100 Hz, which is less than Nyquist rate. Now from this problem, we find Fs will be equal to 150 Hz. But in case A, they give as sampling rate will be Fs will be equal to 100 Hz. So this sampling rate is less than the Nyquist rate. So therefore, X of t cannot be recovered from its samples. Now considering the case B and case C. So from this, in both the cases, sampling rate is greater than Nyquist rate. In case B and in case C, the given sampling rate Fs will be equal to here 200 Hz, and in case C, the given sampling rate equal to 300 Hz. So in these both the cases, the sampling rate is higher than the Nyquist rate. So that therefore X of t can be recovered from its samples. So in this video lecture, I explained how we are finding the Nyquist rate, that is the sampling frequency Fs.